Hypothesis testing refers to the systematic and scientific method of examining whether the hypothesis set by the researcher is valid or not. Hypothesis testing verifies that the findings of an experiment are valid and the particular result didn't happen by chance. If the particular results have occurred by chance, then that experiment cannot be repeated and its finding won't be reliable. For example, in real life, hypothesis testing is used to check the manufacturing process, to plan the marketing strategies. It is also used in clinical trials. Along with that, it is also used in testing effectiveness of essential oils. Hello everyone and welcome to Intellipaat. Before we move ahead with the video, please make sure that you subscribe to our YouTube channel and hit the bell icon for regular updates. So now, moving to the agenda, first we will be knowing about what is hypothesis testing. After that, we will see the steps involved in hypothesis testing. After knowing what is hypothesis testing, we will see the types of error, that is type 1 error and type 2 error, and then we will see what is p-value. So p-value in hypothesis testing is used to show whether the outcomes of a test are statistically significant or not. Once we got the idea about p-value, we will be seeing what is normality and t-test along with the practical implementation. Alright guys, so let's start with hypothesis testing. So what is hypothesis testing? As you can see the term hypothesis, it means assumption. So basically, hypothesis testing is the process of testing assumptions for a population parameter on a sample of data. Let's understand in a clear way. So basically it uses a sample data from the population to draw useful conclusion regarding the population probability distribution. Hypothesis testing provides a way to verify whether the results of an experiment are valid or not. So here we are having two types of hypothesis, null hypothesis and alternate hypothesis. Null hypothesis is denoted as S0, alternate hypothesis is denoted as H1 or HA. So what is null hypothesis? So it indicates that there is no difference between two possibilities. Alright, so it treats everything as same or equal. So let me give an example to understand in a clear way. So for an example, conducting an experiment to check whether the boys are taller than girls from age 10 to 15. So let's suppose this is my null hypothesis. So what will be my alternate hypothesis? So in alternate hypothesis, it indicates that boys are taller than girls from age 10 to 15. So here you can see that in null hypothesis, it will treat boys and girls and it will say that boys and girls have the same height, whereas in alternate hypothesis, it will say that boys are taller than the girls from age 10 to 15. So this is the basic idea about hypothesis testing. So after understanding hypothesis testing, now let's see the different steps involved in hypothesis testing. Alright guys, so the first step that we are having is stating the hypothesis. So basically hypothesis testing starts with stating the null and alternative hypothesis, right? So I have already given you the example of boys and girls. So let's suppose in boys and girls, the null hypothesis will say that they are having the same height from age 10 to 15, whereas alternate hypothesis will tell that they don't have the same height from age 10 to 15. The second step that we are having is collect data. So basically the data or the sample has to be collected in such a way that it is easier for the computations to find the evidence or pattern in the data. The third step is evidence to fail or accept the hypothesis. So basically here the statistical tests are used to gather enough evidence to test the hypothesis, right? Step 4, test the hypothesis. So in this step, based on the test statistics, the null hypothesis is either rejected or accepted. Alright, so the last step that we are having is decisions on the assumptions. The process ends with a decision to establish the assumption made in null or alternate hypothesis. Okay guys, so after understanding the steps, let's see the example of hypothesis testing example. So first you have to state the null hypothesis, then state the alternate hypothesis, and after that you have to make sure that the statistical test has to be done to find the enough evidence, and after that you have to decide whether to reject or accept null hypothesis. So here you can see the example of hypothesis testing, right? Students with height more than 5 feet have BMI more than 20. So this is my null hypothesis. So what will be my alternate hypothesis? That student with height more than 5 feet do not have BMI more than 20. Now we have to perform the statistical test to support the hypothesis, and according to that we will reject or accept the hypothesis based on the test statistics. So this is the basic idea about hypothesis testing. Next, we will see different types of errors. So mainly we are having two types of error, that is type 1 error and type 2 error. So the first error that we are having is type 1 error, which is also known as false positive. So the null hypothesis may be rejected based on the statistical finding, but it may be a type 1 error. So this is a formal definition. Let's understand by an example. Let's suppose any person is having a mild symptoms of dengue, such as he is having nausea, vomiting, and then eye pain. So what will happen here? If the test result says that you have dengue, but actually you don't have, so this is a type 1 error. Now coming to the type 2 error, if the test result says that you don't have dengue, but you actually do, so this is a type 2 error, right? So what happens in type 2 error? You may fail to reject the null hypothesis based on the statistical finding, but it may be a type 2 error. So even though the test results say that you don't have dengue, but you know that you are having the dengue, so this is the type 2 error. And in the case of type 1 error, the test result says that you are having the dengue, but you actually don't. So these are the two types of errors, that is type 1 error and type 2 error. So now next, the concept of p-value is here, and it is a really important one. So let's understand what is p-value. So the p-value in hypothesis testing is used to show whether the outcomes of a test are statistically significant or not. Let's understand in a simpler way. In a simple way, I can tell that p-values are used in hypothesis testing to help to decide whether to reject or accept null hypothesis. So the p-value will lie between 0 to 1, right? So if the p-value is less than 0.05, then you have to reject the null hypothesis, or else you have to accept the null hypothesis. So if your p-value is 0.05, that means the 5% of the time you would see a test statistics at extreme, right? So now you have to consider in your mind that if a p-value is less than 0.05, it is statistically significant. Okay, and it indicates strong evidence against the null hypothesis, as there is less than a 5% probability that the null hypothesis is correct. So the p-value is 0.05, it means it's the significance value. So you can also call it as the significance value, right? So this is the basic idea about the p-value. So after understanding the p-value concept, we will perform tests like normality test and t-test, and we will see how with the help of using p-value, and you will see that with the help of p-value, we will accept null hypothesis or reject null hypothesis. Alright guys, so after understanding what is p-value, now let's learn about normality test. So the normality test is a hypothesis test which is used to check whether your data is normally distributed or not. So once again, here we will take null hypothesis as that your data is normally distributed, whereas your alternate hypothesis will be the data is different from the normal distribution. Alright, so regardless of the statistical normality test we use, we have to make our decision based on the p-value, right? So if the p-value is less than 0.05, then the null hypothesis will be rejected, and if it is greater than 0.05, then your null hypothesis will be accepted. Alright, moving ahead. So here we are having two of the most popular tests to check the normality of a data. So the first one is the Shapiro-Wilk, and the another one is the Kolmogorov-Smirnov test, right? So now after understanding a little bit idea about the normality test, now let's see the practical implementation of it. Alright guys, so I will be using here Google Colab. So let me just go and then write here Google Colab. It will take some time to open. Now I will just click on this new notebook. Alright, let me change the name here. Just let me write here normality test. Okay guys, so it's time to see the practical implementation. So now what I will do here, first I will import the scikit-learn library. So scikit-learn is a machine learning library. Let me just write here from sklearn.datasets. So basically I will import here the dataset, that is the wine dataset, right? So this module, that is sklearn.datasets, from this module I will import wine dataset. So let me just write here from sklearn.datasets import load wine, and let me execute this. So here you can see that we are getting an error because I have to write here datasets, right? So let me just correct it. And now if I'm executing, you can see that my load wine dataset has been imported. Let me just zoom it out. Alright, so after this, what I will do here, I will just create a variable. Let's suppose I will give the variable as wine name, and I will just write in load underscore wine and store into this variable. Now it's time to import the pandas library. So I'll just write here import pandas as pd, and now let's create a data frame, so which will contain a tabular data having rows and columns. So I'll just write here pd dot data frame, and inside that I will write here wine dot data, and for columns I'll just use another parameter columns, and I will write here wine dot feature underscore names. Let me execute this. You can see that I am getting this data frame. Alright, so let me store into a variable. So I will just give the name here as df. Now I want to see the first 5 records, so I will just write here df.head. So here you can see that I am getting first 5 records. Now if I want to see how many rows and columns I am having in this data frame, so I'll just write here df.shape. You can see that I am having 178 rows and 13 columns, right? Now if you see here, I want to see, let's suppose this is a malic acid column. If I want to know whether this data is normally distributed or not, I can draw a graph. So let me just use the matplotlib library. So I will write here import matplotlib.pyplot as plt. So I am using alias as plt here. It's showing error because we have to write here l. Alright, so after importing this library matplotlib, now let's draw the figure of this particular column, that is malic acid. So I'll just write here plt.figure. So let me give the figure size as, let's suppose, I'll give here as 10,5. Okay, and now I will draw a histogram. So for histogram I will write here plt.hist function, and inside this I will write my column name, that is malic acid. So I'll just write here df. Inside that I will write malic acid. Now if I'm executing it, you can see that this is my graph. So by seeing this histogram, we can clearly say that it's not a normal distribution, right? But anyways, I want to perform the normality test, right? So how to perform it? So initially we have to consider the null hypothesis. So what will be my null hypothesis here? That your data is normally distributed. So let me just write here h of 0. This is my null hypothesis. So I'll write here data is normally distributed. So what will be the alternate hypothesis? That data is not normally distributed, right? Alright guys, so after this what I will do, I will import another module, that is scipy.stats. So this module contains a large number of probability distribution, and it is also used to perform statistical test. So let me just write here from scipy.stats, and I will import Shapiro. So I have already told you about Shapiro will test, that it tests the null hypothesis that the data was drawn from a normal distribution, right? Let me execute this. Alright guys, so let me use here Shapiro function, and inside that what I will do here, I will just pass my column name, that is malic acid. So when you are executing this, you will get two values. The first one is the statistical value, and the another value is the p value. So let me just write here the variable. I will just write here stat, and comma I will just write here p value. Alright, now if I want to print my p value, I will just write here print and p value. So clearly you can see that my p value is less than 0.05, but it is an exponential form, right? So let me just change the form in the floating one. So what I can do for that, I will just write here print p is equal to, I will write here percentage 0. So let's suppose I will give here the value as 16. Alright, so it will give me the up to the 16 numbers after the decimal, and I will just write here percentage p value. Alright, so here also I have to write p value, p underscore value. Let me execute this. On execution you can see that this is my p value, and after decimal you can see that I am getting 16 numbers, right? So after seeing this, you can clearly tell that p value is less than 0.05. So we have to reject null hypothesis, and this is not a normal distribution. That means your data is not normally distributed. So let me give the condition here. If p value is less than 0.05, so I have to write here p underscore value is less than 0.05. You have to write here print data is not normally distributed, reject null hypothesis. Alright, and the another condition that I will give, else print, let me just, and I will change here, else data will be normally distributed, and you have to accept the null hypothesis. Alright guys, so on execution you can see that, let me just remove this. So on execution you can see that data is not normally distributed and you have to reject the null hypothesis. So this is the way to perform the normality test. Alright guys, so after understanding what is normality test, now let's understand about t-test. So a t-test is a statistical test which is used to compare means of two groups. So that means if you are having two groups, so it is used to compare the mean of the two groups, right? So in that case the t-test will be used. The t-test is oftenly used in the hypothesis testing to determine whether the two groups are different from one another. It also tells how much the significant difference between the group means are. So there are some assumptions in t-test that you have to do. So your data must be continuous. The data must be normally distributed. Along with that, the variability of the data in each group should be similar. Alright, and we know that we have to consider null hypothesis and alternative hypothesis too. So after understanding the basic idea about t-test, now let's see different types of t-test. So we are having mainly three different types of t-test, that is one sample t-test, two sample t-test, paired t-test. So now what is one sample t-test? So the one sample t-test is a statistical hypothesis test which is used to determine whether an unknown population mean is different from a specific value. So let's take an example. Let's suppose you are having a population and from that population you are taking the sample. So you will compare the means of the sample and the population, right? So coming to the next test, that we are having two sample t-test. So it is used when the data of two samples are statistically independent, right? So in simple terms, I will say that the data should be independent. Now, the next test we are having is the paired t-test. So paired t-test is used when the data is in the form of matched pairs. So this is the basic idea that you got. So now let's see into the practical implementation to get more idea about all these tests. Alright guys, so let's come back to Google Colab. Let me change the name once again here. I will just write here t-test. So here what I will do, let's create here a variable marks and I will create a list and let's give some marks here. So I will just write here 97, let's suppose 23, 45, 67. I'm just taking random values here, 78, 90, 65, 71, 45, 33. Let me just insert some few more values. Alright guys, so let's suppose that these are the marks that has been scored by the student in any particular subject, let's say maths. Okay. Alright, so I just want to know the length of this marks variable. So total 18 elements are there in the list, right? Now what I will do here, let me just import here numpy library. I will just write here import numpy as np and I will just calculate the mean of this marks. So I'll just write here np.mean marks. So here you can see that my mean is 67.77, right? Alright, so I was talking about the t-test, right? So you can see that this is my population and I want to take the sample from this. So that's why I will be using here numpy function. So I will be using the function here random choice, right? So what I will do here, I'll just write here np.random.choice function, and inside this choice function, first parameter I will give here marks, and let's suppose I want to take the sample size also, right? So let me create another parameter here. I'll just write here size, which is nothing but the size of the sample. So let me give here the sample size as 6, alright, and I will write here size. So what will random.choice function will do here, it will take all the marks and out of that marks it will take randomly 6 samples, right? So let me just store into a variable, and now if I'm executing here print a, you can see that these are the sample marks, right? Random 6 sample marks, 100, 90, 23, 79, 45, 23. So this is my population and this is the sample. Alright, so it's time to perform one sample t-test. Okay, so t-test is used to compare the means of two groups, right? We know the mean of this population. Alright, so what I will do here, we will be calculating the p-value. So p-value basically tells the probability for hypothesis testing to be true. So what will be my null hypothesis here? That the means of the sample and the mean of the population are same, whereas my alternative hypothesis will be mean of the sample and mean of the population are not same, right? Okay. So after stating the null and alternate hypothesis, now what I will do, once again I will be using the, so scipy.stats is used for the probability distribution. It is also used to perform statistical test. So let me just import this module. So I'll just write here from scipy.stats and I will import here, or let me just write as alias from scipy.stats as stats. Yeah, so I will write here from scipy.stats import stats. Okay guys, so now I have to calculate the p-value. So for that, what I will do here, I will just write here stats dot, and for one sample t-test, I will be using a function which is t-test underscore one sample. So this is a function, and inside this function I have to give two parameters. So the first parameter will be my this one sample, right? This is my sample one. So I'll just write here a, and the another parameter that I have to give is nothing but the mean of the population. So mean of the population is 67.77. I will just write here 68. All right. So this function will give me the statistical value and the p-value. So if I'm executing it, you can see that I'm getting the statistical value and the p-value is 0.59. Okay guys, so let me just print the p-value, or else I have to just assign the variable. Let me assign the variable as stat and then p-value. Let me print the p-value. So my p-value is 0.59. So that means our null hypothesis is accepted. That means the mean of the sample is equal to the mean of the population. Now I have to give the condition here. If p is less than 0.05, then print reject null hypothesis, else print accept null hypothesis. So here I have to write p-value because I have given the name as p-value, right? So this is my variable name. So here also I have to write the same variable name. So here you can see that we have to accept the null hypothesis. Now here if you see that in the population my mean was 67.7, right? Now if I want to see now what is the mean of this sample, so I'll just write here np.mean and I will just write here a, and you can see that it's 82.66. So that's why I am getting here the p-value as 0.59, right? Now let's suppose once again I am executing this time I'm getting 66.5, right? Now if I'm executing once again here, so my p-value will change. You can see that my p-value has been increased this time because I'm using here the random function, right? Random.choice. So it will take the random samples from the population. So every time you will get the unique p-value. And since you can see that now my population mean is 67 and here the sample mean is 66.5, so my p-value has been increased also. All right. So this is the basic idea about the one sample t-test, how to check whether to accept null hypothesis or to reject null hypothesis. Next, we will see the two sample t-test. So let me write here two sample t-test. So what happens in the two sample t-test? We compare the means of the two independent groups, right? So let's say this is the marks that is scored in subject maths. Now I can take the marks that is scored in the subject science, and then I will compare the sample mean of maths and the science one. Alright guys, so let me once again here import the scipy.stats module. So I'll just write here scipy.stats as stats, and now I will be using once again numpy, that is np.random.seed. So why I'm using this np.random.seed, because this method is used to initialize the random number generator so that you are not getting the random number every time. So you can give here any value. Let me give here the value as 7. Alright, let me execute this. Now what I will do here, I will just write here mark. Let's suppose the variable name here is marks1, and I will be using here the Poisson function. So I will write here stats dot Poisson dot rvs, Alright, and here I will be writing here LOC, that is location 18. So what does it mean? So it means that you are initializing the value as 18, initial value. So let me just give that the minimum marks is, let's suppose 33. So this will be 33. Now when I'm writing here mu as, let's suppose 55, so this means mu is the mean of the function. Now I'm writing here size. So what is size here? Size is nothing but the size of the sample. So it will be, let me just write the size as 100. Alright guys. So here you can see that I am using here the scipy.stats.poison, right? So this is a Poisson discrete random variable. Okay guys, let me execute this. And now after executing this, I will just calculate here the mean. So for that, I will just write here marks 1 dot mean. So the mean is here 87.98. Alright. The same way I will create another variable of marks 2, and I will be using the Poisson distribution. So once again I will write here states dot Poisson dot rvs, and here the, let's suppose the minimum marks is 23, and here I will give the mean value as, let's suppose 30. No, 30 will be less, so let me just write here around 60, and then size I will give the same size, let's suppose 100. Okay, and let me just calculate the mean of this, and mean of this is 83.57. Now as I told you that in 2 sample t-test we will calculate the mean of 2 independent groups, right? So here you can see that and relate that this is the marks that has been scored in the math subject, and this is the marks that has been scored in the science subject, and we have calculated the mean of the math subject, mean of the science subject. Now we will be comparing it. So what I will do now here, I will just write here stats dot t-test, and for the 2 sample t-test I will be using here end. So earlier we were using the t-test underscore 1 samp, right, for 1 sample t-test, but here we will write t-test underscore ind, right? And now I have to pass the parameters. So the first parameter will be my marks 1, second parameter will be marks 2, right? And I will write here equal underscore where false. Alright guys, let me execute this. And here you can see that this will again give me statistical value as well as the p value. So let me write here stat and then p value. But p value is in the exponential form, so let me just convert into the float. First let me print the p value. Alright, and now, so this is in the exponential form. What I will do now, I'll just write here print. I will write here p underscore value is equal to percentage, and let me just write here 0.1, let's take 15 f. Okay guys, you can see that I am getting error because I have to remove comma from here. Now you can see that I am getting the p value 0.0005, which is less than the 0.05. So our null hypothesis will be rejected. So let me give the condition: if p is less than 0.05, print null hypothesis is rejected, else print accept null hypothesis. So here I have to write p value. So you can clearly see that our null hypothesis is rejected. Why? Because p value is less than 0.05. So our null hypothesis will be rejected in that case, and if it's greater than 0.05, it will be accepted. So this is the basic idea about 1 sample t-test and 2 sample t-test. Okay guys, thank you for watching the video. Please do like, share and subscribe.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.